Hello, my name is Brendan Madden. I'm the CEO of Tom Sawyer Software. I'll give a little bit of my background. I have 2 degrees in physics, one in physics from Ithaca College, and another degree in applied and engineering physics from Cornell. And I worked since from like 84 to 88 or 89 at IBM T.J. Watson Research Center. So I worked in graph layout problems, or what we used to call it the network layout at the time. And so I worked on one system there in drawing SNA networks. And later I worked at IBM Santa Teresa Laboratory, and I built another for something called 80 cycle and repository, and I built automatic layout that drew ERDs, schema results, query results. So that was the old days was all C and C++, C libraries and OS2 and all that. Then I worked at Vitalink Communications and bridging and routing, and then started Tom Sawyer Software in. Actually worked for about a year in my house in '91 and incorporated January '92 in Berkeley. So actually we're working more than 20 years. So I think we're probably the first American kind of graph technology company. So I'm not sure that's true, but I think it might be true. So, so I'm in this field now for at least 25 years, I guess. So, so in this talk, I'll just introduce, our products. In the 90s, we built. We started basically with automatic layout. We wound up getting customers like Semantic Timeline, Sun Spark Compiler, Bay Networks. So we had these portable C++ libraries, and we would license into existing graphic systems. So we started with just automatic layout, and so the question is, so what we had was, and then we started building graphical products, which became later became a visualization or presentation architectures. So. And as we built layout and got more advanced in the late 90s, we started to do compaction or reachability. So we started to build a lot of analysis technology to help you do better layout, to format the drawings better. So just at a core, we were largely client technology. We licensed to software and. So we had a lot of people like Alias Wavefront, Embarcadero, Cisco, a whole bunch of companies like that so we had basically license agreements with them. So, so let me say, so what's different is, say compared to something like a Visio, where they were an interactive, mostly manual diagram creation. We were largely a drawing canvas technology with batch interfaces and interactive diagramming interfaces, event handling, front-end work. So what I'd like to say is, well, what is visualization to us? At least what was it? It's really like the drawing canvas technology, viewing tools, editing tools. So you don't need a layout technology. So in the old days, people had lots of case tools, object modelers, and they're usually done by hand. All the drawings were done by hand. So I saw that as that was the opportunity. I said, there's all these companies that need help. So that was the reason to make a business or a company. So visualization was presentation architecture. So it's canvases, viewing architectures, editing architectures, which is and then batch loading, interactive diagramming, printing, exporting. So that's kind of the idea of visualization. So then the question is, well, that's an architecture for your application, the graphical architecture, and the toolbars and context menus and all that. Then the question is, well, when the data grows, you need to you would like to automatically format those the drawings that you have on the canvas. So the question is what is layout to me? Layout is taking so in order to be able to format something geometrically, you need objects with sizes and shapes. You need, at the geometric level, you don't need graphics really. You just need nodes, maybe polygon representations, or image and text representations. So you need a set of nodes, a set of links, a set of maybe labels, attachment points to nodes, this kind of thing. And then the question is, well, draw in what style and for what purpose? So there's something like a drawing specification that you need, which is like, well, I would like a schematic drawing, I'd like a network drawing, I'd like a directed graph drawing, something like a process drawing. So it's the idea of, layout is about geometry, graph analysis is about, so then the question is, well, what's analysis? Well, analysis is, in graphs, what you have are, the graphs are, it's a set of nodes or vertices with, simple graphs have like sources and targets, so you can have directed graphs where the link direction matters. You can have undirected graphs that represent just a connection between things, and then you can have mixed graph representations, like where you do analysis and some links have direction and some don't. So we have combinations of this. Then there are things like hypergraphs, where you might have, a link may have more than 2 endpoints. So you see that in like bus representations, smart grid representations, where multiple things are attaching to, multiple links are attaching to a bus structure. So it's sort of like a virtual, a multi-endpoint link. So analysis, so that's why I think visualization's like a house or a building with floors. Layout is like a service that runs against the input, and analysis also. So visualization, layout runs against geometric representation, and analysis runs against topological or connection-oriented structure. So, okay, so we began. We had just a little background. We first did C++ technology, then we did Borland-Owl, MFC, ASP. So then we did Java, swing-based technology. Then we did ASP.NET, JSP. So we had 5 different presentations. So it's sort of like having more kids. You just keep having more kids. We had hundreds of clients that used just our, what we call Tom Sawyer visualization, which is, and the way customers worked was they just populated our APIs in code. So, and what happens is they would write tens of thousands of lines of code from their data model to our presentation architecture. And then that created a whole, upgrading problems as time went on. So I'll continue just quickly. So I'm going to show what we used to do and then what we do now. So I'm going to shortly start into demos. I don't want to spend too much time. Yeah, as you know, so we're based in Berkeley. We have Australia, Latvia. We have a lot of R&D in Latvia. We have a new office in Mexico City. And then that. So markets where we sell, just quickly, we have government clients like in intelligence, police, social services, entity and attributed data largely. And we have a lot of telco, network management like Riverbed, Cisco, BMC, CA, they all use us. CMDB applications. So just quickly, so these are some of the customers. You can see there's like multiple markets, schematic markets, movie making, networking, UML modelers, software code analysis. We're starting to get into smart grid projects, and so it's, and starting to get like other kinds of companies. So the question is like, well, where are we focusing now? We're doing link analysis applications, sort of like I2 in England or Palantir have done. We do a lot of network topology, schematic views. business process views, and then we have new map technology. So I'll jump quick. Now, these days, though, we're going from data all the way to views of data, and with update and commit architectures, so that we can bind to structured, semi-structured, unstructured data sources. We have like a federated architecture plus API-based. So we can connect to Excel, text, XML, SQL, RDF data sources, NoSQL sources like Objectivity's Infinite Graph or Neo Technologies interfaces, web services integration. We have new REST integrators to sit. So we kind of say it's data integration, the data model, like what kind of app are you building, visualization, interaction, and it's really graph analysis. Social network is more trendy, but it's really graph analysis technology. So our main line is now something called Perspectives. I'll show it in a second. It's just, and I hope it's okay. We used to do API-based work, and now we're moving more to design-oriented application building. So I'll show that. And these are just some demo example apps. So our software is kind of becoming like a visualization and a data integration, visualization, analysis middleware. And with a single app design, you can go to, so the idea is you design an app once and so we do design, preview the app, deploy. And the deploy process, you can make a late decision on where the app is being deployed to. So we can deploy to Swing or SWT desktop apps in Java, image map web apps. Now we have new HTML5 rendering technology. And so the idea is you design it once and all the bindings to what's the data model, where's this data coming from, what kind of views do I want in my app. And you do that all without concern. Sorry, you do that all without concern for the actual deployment. And and then towards the end of the year we'll have touch and mobile. Actually, in June we also have WPF deployment for .NET, and then we'll have IIS HTML5 web apps for Microsoft shops too. So the idea is the same design will port without change. And so we're hoping to get the touch and mobile done by the end of the year. So yeah, design once. We have years of work in scale work. So you can see all the ways to integrate the data. And then the idea is instead of APIs, what we've done is wrapped it all with configuration points. So what you used to do with APIs, and we still have APIs, but the idea is, customers' code would get fragile, the engineers would leave, there would be a lot of code lying around, and then have new people. So the idea is we come up with like project-based design. So you say, what data model do I work, what's my data? Patients, doctors, hospitals, or it's network switches, devices, routers, bridges, or it's suspect, criminal, so you build a data model. So I'll just continue. Then instead of coding, we've built expressions and rules to map data from one place to the next, and I'll show how that works. And then we've done rule-driven, synchronized views of data. So the idea is you have your data sources, many of them. You load them. You specify the schema, or you dynamically load. You populate a data model. So you can suck the data into our data model. Then you say how many views of that data do I want, and from what perspectives. You say, well, I want a tree control, a table view, several diagram or drawing views, maybe some map views, maybe some charts. Charts will be later, but so I'll show how that works. And maybe I better, yeah. So, and then we also have a lot of viewing technology. We have global for layout. We have global layout, incremental layout, constraint-based layout technology, and I'll demo that in a little bit. We have lots of labeling technology, routing technology, so I'll show it in a second. And then in analysis, we have about, what I call graph analysis, we have about 35 algorithms so far. So we have, and we kind of classify them into like partitioning, traversals, centrality measures, network flow algorithms. So, you know, pathfinding algorithms. So that's analysis is like reachability, impact, with just against the. So like if Amazon were building, you know, recommendation engine, or Netflix was trying to serve you up the next movie, or Google's trying to give you 3 paths between the 2 cities, that's all analysis. You just need the network and the costs, you know, the costs and capacities on the links, or you know, the speed of the road becomes an attribute on a link, or so. Okay, and then we're doing a lot of temporal work, which is timelines and time-oriented data. So I'll show, and then okay. So this is more technical, but all the browsers, you know, with the latest image map JavaScript stuff, and you know, image map views, HTML5 is like no plugins, no applet stuff. So let me, maybe I'll quit the PowerPoint. Okay. So first I'll just show a little bit of just from core visualization. I'll just show you a simple image mapped web view. You know, should just show you a pure thin client just quickly, and show you like the speed of the layout technology. So let me just start a server, and so this is a very small view. Okay, that's odd. That's strange. Okay. I'll open another one. Strange, I'm sorry. I have an internet connection, but okay. I don't know what's going on. Okay.
Is it wireless? Because it doesn't look like you have connection.
It's not connected.
I think I have a network. There, I don't know. I'm not sure. So, okay. So this is just simple our visualization product, and I'll just show. So this is an example of what we call circular layout. It's a 1500 node drawing. So we apply a clustering on the network, something like multi-way ratio cut clustering. We determine the clusters. We determine what nodes are connected only to other nodes in the same cluster. So this is running on a 3 gigahertz MacBook. So I'll show you. That's something like a circular layout. That's so a 1500 node symmetric layout. You see, it's about 1,000 nodes a second. So that's a example of a pure image map representation. Then I'll show. So you see the speed, and so this is a no plugin system. Then I'll show something like. Hang on. So this is a directed graph representation of it's just an XML. I'm just loading XML here, and so we have a set of nodes and links and labeled nodes and labeled links. So, for instance, here, this is a top-down hierarchical drawing. We can do different styles of layout, like something like, so that's a circular clustered layout with animation, labeling. We have orthogonal automated drawing. You see that's, we have, you can kind of see there's, we have a precise shape clipping to the graphical images, attributed labels to the left of, to the right of. You can have nodes with labels, connections with, attachment points like ports or ground pin with labels, that kind of thing. And then we have, a symmetric view of the same data, which is like mesh view. So I'll just show a little bit of the, like something like an orthogonal layout. Just to show you, we have like a schematic style technology. So for instance, if I took something like that, duplicated it, routed, you know, make some links, like something like this. We have something called like what we call incremental layout, which is a minimum adjustment formatting system. Something like a least squares solution, but it's more advanced. But so you'll see something like this, cleanup, and there's like a minimum movement schematic. Or something like to show if you see something like this, we have integrated labeling technology. So if I, for instance, if I said, hello, oops, I am a very long label, like that. You know, now in something like a Visio technology, you'd have to, okay, now spend the next 6 hours cleaning it. No, it's true, hours. So, you know, instead, like with our software, you know, you just incremental layout and, you know, minimum movement. But, so, you know, so then you say, well, what if I have other information in my data, like I have groups, or I have, you know, I want to bias this thing. So we have constraint technology. So you can see here we have alignment constraint. So I'm not going to show them all because it takes me a little while. We can do it by API or configuration, or you know, here interactively. We have alignments, which are like draw critical path, align the nodes this way or this way. We have, you can fix nodes to certain locations, like physical XYs. We have bands, which are like something like swim lanes. You could say, I have a band of nodes, and then you can say, put the bands left to right in this order. Groups, open and close groups. So I'll show that, for example. So I want to take, just quickly, take this node, and this set, and that set. Maybe I'll change the color, just to, if I can find it. Then I can say, I want those in a closed group because they mean something in my data. It's by subnet, or it's some key attribute that I'm trying to visually express in the data. So, okay, I make a new constraint, add those nodes. Okay, now if I lay that out, so let's do it again. Now they're in a group in the drawing. If I do it in a different style, you know, even though they're not connected, they're placed together in the group. Or with circular layout, they're in the same group. So you can see how the clustering is performed, and we pull nodes inside the cluster and we do a constrained mesh, constrained layout there. So I just like to show a little bit for speed. So that's you know, there's a whole set of those constraints, and you can apply them. So this is a pure visualization product. Then this is our older API technology, and we also have you know, technology like you know, nested drawings. So let me show. Maybe I should make it bigger, I'm sorry. Yeah, something like this, right? So say I just, in this drawing, if I had twice as many links, like just, okay, select all those links, duplicate them, you know, clean it up. You see, it's a, you know, you can kind of see there's a, you know, it's kind of clean, undo, redo, you know, everything is like that. So we have this kind of very flexible, constraint-based, incremental drawing technology. So back to this one. Okay, let me undo everything. Go. So yeah, you see, okay, back to what we started with. Show something a little bit larger, like something like that, and then add some links to the data. You know, something like that. And then, for instance, maybe let's go left to right with orthogonal line routing, apply. So you get an idea of what people use this for, like manufacturing process. You know, so you see something like drawing like that, you see. So there's, you know, fine auto routing, labeling, you know, clean, you know, you can say attach on the left, right, top, bottom, source target, that kind of thing. So this is our older technology where you use APIs and it was the view of the data. It didn't give you the bindings except by API. So now the question is, well, what next? And so quit out of there. Leave this one, get out of there. Yeah, I don't know what happened with the load. It's never, the start, I don't know, that was strange. Okay, quit that. Okay. So now I want to show something called Perspectives, which the problem was we were a licensing company, we were kind of trapped because everybody was an API user. We couldn't sell to a bank, we couldn't sell to a pharmaceutical firm, we couldn't sell like direct with integrators. So what we started in like 2005, we started building, okay, people have data, it's all over the place, and they want views. So we started to say, so we built all the so the idea is instead of having everybody bind the view in code from their data, we built the pipeline all the way back to the, so what we did is, those views are like graphics, right? That was just nodes and links on the, you know, with, oh, yeah?
You mind if we ask questions?
Okay, yeah.
So when you were changing the label, for example, in the demo, was that actually changing the underlying data also, or was it just changing the presentation?
That was a front end edit, but we actually have I'll demonstrate that now where we have so this was the viewing side. Now we have another product line that has, so basically we built Perspectives, which has the idea of a, you know, schema, which is like, what is my data representation? You know, it's like I have devices, you know, like, you know, the classic example, network device has a IP address, a host name, you know, whatever. A link has a connection speed, you know, so, or, you know, if it's patient, it'll have, okay, social security number, his name, date of birth. So we started to build the idea of, so schema is representation, you know, what is the model, what kind of data. Then we built an attributed data model, which is like a set of elements and attributes. So basically you want to load data into a model that's such that it satisfies the schema. And then we started to get into dynamic schema projects where the schema is not really, you can't really specify it in advance, but you want to build it dynamically like a lazy schema. You know, so what happened is we built schema, model, then we built integration architecture. And the idea is, so I'll demo it, it'll be easier. So Perspectives is now at version 5. The idea is you can build an app that has an update process. So the idea is you can build an app with numerous data sources. Just where it used to be by API, now we have a project-based app design. So where we use all those APIs that you would write, now we have an XML definition of a project, which is a mapping from the source all the way to the graphics and the behavior of the app. So for instance here, I'll open an example. So here's just like maybe we have a whole bunch of projects by industry, so people, you know, get comfortable in their own data space. So for instance, like in a networking example, like a network editor, like you're saying as well, I want to create links between data, or if I create a link, what does that mean, right? It has to be, so basically what we've done is we have something called a between tool, which is not like strictly adding a link. It's actually a model. Every user interface change is a model action with synchronization to multiple views. So like, for instance, creating a link between two people might create a manager relation based on the rules you've written, the schema. So you want to say, and then, so for instance here, I'll open, so like a network editor project. So I'll open a thick client first, just to. So here you can see on the left. Is it big enough to see? Or see here on the left, I've said I want a networking application. So you say, well, I want to define my data. So we've got a schema. So here in this, we built this one by hand because this is one of the earliest ones. You have like device, connection, status, region, type, location in the data, and you can say what attributes and what is it a key, primary key, or is it a string, or an IP address, or a float, or a date, and so then the idea is you say, well, where's my data? In this example, it's coming from two Excel sources. One is giving me the devices and connections, and the other one's giving me status. So we have the idea of like bindings to the data. So you can say, well, what are my bindings? You can like click on a device, say, so we have an Excel data source here, and I can load the Excel content here, and then I can say, well, that device click is column A. It's like point click to map attributes, data to the sources. So that's and then the same. So and then another data source here, so that's the status data. So you can basically. Multiple sources. It can be text formats, XML, SQL, RDF, data, API, web service. Yeah. Oh.
I remember something a while back called NDA, model-driven architecture.
Yeah.
XMI for the sort of agnostic data representation. Is that what you've done as the foundation for your product?
Yeah. Well, it's not XMI based, but it's sort of, we have so the idea is what we have is a schema model. We have integration architecture and you can have filters in the integrator loading. Like in big data, you've got too much. You want a subset even in the filtering, even in the integration. We can subset the data during integration, and then we have filtering in the views too. So I have a data model, and I want to generate views of the data, maybe based on. So I'll show some filters in a second. So what we have here, and then we have the idea of templates, which are something like what is the graphical representation of that? Oh, it's an IP view, so it's got routers and switches, so you can actually separate the visual representation, the type data, separated from the data source. So our concept of a drawing template or a graphical is something like a Visio stencil, where you say, what are my graphical. And we're building we're going to have UI designers we have so I better show, yeah. So we have the idea of designing templates, which, so here, for example, I can say that's the UI representation for, and we have attributed scene-based graphic system that you have a drawing scene, and under certain conditions, you render elements of the, like as you mouse over, as you resize, so level of detail. So for instance here, I can say, let me make it a little bigger. So what we have is so this is a multiple views of the same data, and no matter where you click, you have full multiple view synchronization of the data. So for instance, over here, we have a new search interface. You can say, I want to search for all the routers. And then everything is, so now I just flip through the result sets, and it's all, it's all synchronized and integrated. We have, so for instance, so we have all, so I didn't really show the front end, but we have, we have marquee zoom, focal zoomers, and level of detail. You'll see here now at different so at the outer level, you see how there's no labels. So we have low and high resolution drawing So we show less when you're zoomed way out and you can't see it anyway. But as you zoom in, like we can have you know, more complex representations at different zoom levels. So where each, you see, so as I zoom in, I'm deciding to show more. And so then, you know, we have things like panning technology, kind of, you see, we can have like monitoring technology, you know, so you can say, you know, showing, so we have a lot of network monitoring customers. They do, you know, data change and they want to represent it visually on the console. So that's an example of like, then we have things like, the idea is you visually define, you have your data and you write rules to organize your tree controls, your tables, your properties. You say what attributes you're interested in showing when you click on anything. So for instance here, in this one, like I can say, well, let me do some filtering or some grouping. So I can say, let's group by location, and that view is dynamically generated. Or I could say, let's group by region, and it's so the data. So I'm not hard coding the view. Everything is rule driven. Or for instance, here we have filters to say, you know, or I can say just come over here and you know, double click and just look at that, or you know. So I can drill up and drill down through the structure, and I can say, well, I have, so all these filters, everything I was saying, every user interface action goes back to the model. So, like for instance, if I turn off east and west, now the views are empty because there's no more data. Oh, yeah.
Are you using an XML database as the data store in XSLT to generate the dynamic views?
We can bind to pretty much any XML, and our customers can write XSLTs. I'm not the XML guy, the binding, but yeah, you can write. It's really like we've bound to really complicated schema. So for instance, so the idea though is you can, you know, dynamically, you know, sort, search, and like so for instance, that's a simple. And I'm sorry, I realized I didn't. And this app is actually an editing application. You can, so for instance here, I could, you know, that's actually adding. That actually adds an entry to the model, and then all the views update to reflect the new entry. And then we have over here, you can see update technology and commit. So we have actually kind of we can do federated commit to multiple data sources, if that makes sense. So we have federated update and federated write back. And we use the model that we say the data wins if the data's been updated from another. By default, you know, if there's a conflict. So that's some example of, and you see here, like right in the front end, you can say, well, in the drawing view here, I've got like the toolbar system right here. See, so I've got save as image, you know, print setup, print preview, print, and you visually define the left to right ordering in your toolbar, and you can write custom tool buttons and custom context menus. So for instance here, just to change the behavior of this app, since I said when I basically do design preview, when I save this project, it saves an XML definition. When I build an app, you take the libraries, you know, the jar files, the WAR files, the DLLs, along with the project, and you just write what used to be 10,000 lines of code is like 1 or 2 pages of loading code in HTML. You know, in HTML or in a Swing app or SWT app. So all that code has been captured in a project. And so for instance, to change, you see this app here, if I said, okay, how do I, you know, print setup on that? That's okay, 2 columns, okay, you know, that's the preview of that app, you know, that's a preview of that printing. But you say now I want to change the app dynamically. You could say, okay, I don't want save as image, I don't want separator, I don't want print setup, I don't want print preview, and I don't want print anymore, and no separator. Just close that, regenerate it, the app has changed. So all this code to go back to, so the idea is you can dynamically, quickly change an app, and it's actually, it's fast, it's not interpreted, it's not scripting language. It's not a, so it's the whole develop preview cycle is brought way down. And then the idea is similarly the same app is to go to a web, the same design, go to a web app. I've got, you see, it's the same behavior. You know, same behavior of the trees, tables, same search. This is an image mapped web app. So that's an example. Or in the latest, we just released same design now to HTML5 front end. And now you see the front ends here are now it's animated in the web. So we have full rendering technology, level of detail. Like here, you see the same. You see the same level of detail rendering technology, and no change to the source app. It's just deployed. So you see like this, layout technology in the browser. It's animated now, so it's not a image map. Here you see the image map view. It's a little bit different. It's you see this one is more. And then we have overview technology like this. So you see it's more on drop. It performs an action, but whereas the HTML5 one is all, you can do, basically it's all using HTML5 canvas, and it's a whole new, but the idea is, and we use GWT technology from, and then, you have a question? Yeah?
I was just wondering, do you guys run the layout algorithms on the client side, or is this connected to a server that's...
Most of the, well, layout is designed as a service right now. We have so our layout analysis technology all has algorithm input, algorithm like .run, and an output data structure. So in order to do things like, so you can actually take, so we run layout on the server. We also can do, so we're talking about JavaScript layout, and so basically we're heading towards what we call an integrated diagramming system. We're capturing the, I was showing those templates. Well, we're going to capture the specification in those templates in the next few months, so that where we used to have layout, it's more like satisfying an industry representation, like smart grid or business process drawing, UML, whatever that. You capture the specification in the template, and the idea is every user interface action will rule check and satisfy the spacing constraints, or so right now, yeah, it's usually server, but if it's a client app, the layout's local, but it's fast. It's I'll show something larger so you see something like this. So something like. And you see we have animated link creation, and oops, sorry. So you see now the same technology I showed before, but running. This is server-side layout. We have a client-side model here because it's we have the in the image map client we're really sending hotspotted image data to the browser, but in this version we send the unique set of user interface elements over to the client. So we have actually a client model in the HTML5 canvas. So we'll have the ability to do kind of in HTML5 generate the layout into the browser if we feel it's the right move, the right thing to do. Yeah.
So, is this real time or not? I mean, can you grab real time data?
Oh yeah. Yeah. It's all this can all be API driven, model driven. So most of our customers have they do sort of an API model based integration. So we have new REST APIs. We've done push data model in Java 7. So you can actually change so that's a newer technology we're playing with, where you can actually change a property and update the views. So we've done that with a few customers already.
So if you're grabbing real-time data and you do one of these
these federated updates across data sources. Let's say you have your schemas defined and you have 5 different data sources, just for argument, right? You update something, and now that federate push has to go back and update all of these things. I'm trying to understand with the disaggregate data source how it keeps track of where everything's supposed to go out to the different data sources that you're pulling from.
Well, the integrator architecture has bindings. So we have the schema, which is like the target. We have the integrator bindings at the sources. So somehow there's a model. I didn't write it, so I don't know.
Oh, that's fine.
But there's a model. I stopped coding in '98, so. But I do requirements. So
It's complicated.
yeah. But here you see. So yeah, this I could just say, you know, I could go right over here and commit that, and it would write back to the Excel.
Okay.
Yeah, if that makes sense.
So if let's say you have a Hadoop data store, and you have a bunch of sensors that are out in farmland somewhere, and you're going to do a graph representation of all the sensor data that's coming in, right? And for some reason or another, you add a vertices and a node to the graph, right? I'm trying to figure out how that then goes back out and updates those data sources. That
well, we have so we have a model event system. So you have a view, view of data. There's a connection to the model. There's a model event system that like adds a model element to the model or adds an attribute to the model. We also have something called computed attributes where you can say, I've got a model, add some attributes. So for instance, say I want to store the so we have like, if you want to save the diagram, save the users, we have new persistence where we can actually persist the current drawing to the data, back to the data source, things like that. Yeah. Oh, go ahead.
You mentioned Word files, so it sounds like you can create a model and its constituent components deployed to a server container, let's say Tomcat, and sort of related to what you were saying, if you're viewing that on a web page, is that whatever changes you make being sent back and stored on a server that's connected to that web application?
Yeah, if you want, that's exactly what it does.
Got it.
So what's happening is people are building like, like they're doing design editing apps, process. Like here, I'll show you like, here's for example, like a business process example, like where you can edit, for instance. So this one I think also has, you can, so do an HTML5 view of a process. And so this is, we have user interface views of, all the transitions, so you have a custom, and you have custom tools here too, you see, like, add a resource, and they actually add, instead of adding a graphical thing, they add an element that satisfies, types in the model. So so you can actually do checks and, pop up a dialogue or whatever you want to do. So, but here, for instance, yeah, so, so in here, like for instance, this one is an editing app where, we could easily, and it does, some kind of dynamic, it animates the link ad and calls incremental layout and, or, oops, yeah, like collapse that view, something like that, collapse, expand. But you could actually write that back. You could write the drawing back, or you can write individual ads, or you could say, I want to delete that. Oh, shoot. And we also have, there's a bug, I'm not sure. We actually have model-based undo. So we have a reentrant model, and we have model, like undo redo in the browser is actually a model undo redo. It actually undoes in the data model that so basically we have filtering between the model and the view, and everything is expression. So basically you can have all these attributes in the data model, and you can say, I want to write a rule between that data property and that graphical element. So we have our own expression language in between the data and the view.
You know what this sounds like? It's this component-based event-driven architecture. It sounds like JSF.
That's fine.
So I better show an analysis example before. Oh.
Can I ask, before you leave visualization, do you have any layouts for much larger graphs, like 1 million nodes? Or
We can
100,000?
do, so We can do tens of thousands in, so I'll show, okay, this won't be the largest, but, so we can do, in our symmetric layout, which we can do like 11 or 1200 nodes a second, something like that, on a laptop, you know, not server class. So I'll show something like a social networking example, just to quickly. We have a cloud technology in development that will come out this year, which is designed to be a scalability technology. So we have something, we bought, my two brothers built a web search company. So we had visual search. So we're kind of releasing that in pieces. So we have a scalability backend called, we're calling it Tom Sawyer Cloud to be, but it's really multiple, you can deploy apps onto multiple compute instances. And so we have to do it in pieces because it's too big to ship it. So I just like to show here something like, okay, this is an image, this is I want to show maybe a little bit of analysis before I run out of time. So this is you can see in this one, okay, 40 companies, 570 people, and 750 relations. So this is this is SEC data, like who's the board member, compensation committee, director of a particular company, or who's connected to multiple companies, or their VC on multiple boards, something like that. So you can see the layout here. Something that's a circular, symmetric. We have a drawing rotation. You see it's like there's an optimal rotation of the drawing so that you fit the canvas as well as possible. Something like orthogonal, we have layout cancel, multi-threading, things like that. So here's something like, if I was to show, like I can say, well, let me only show only nodes with let me show only nodes with at least 2 connections. So I filter some data, maybe run incremental layout on that, get a new drawing. So you see kind of, you see a nice area. We have overlap free. We're like the only company that can do this, I think. It's like drawings where there's no overlaps in any structure with an orthogonal drawing. And so you see, overview technology like that. So then you say, well, that's, I've filtered out like the less important people or the people only connected to one. Let me go to a social network view of that, which is that's the same data and saying, well, if 2 people are associated with the same company, make a link between the 2 people instead in this view. And then you want to say, so in this example, we're saying, okay, I've got this network now. Maybe who are the most highly connected people? So, like for instance, in this one, we run like between the centrality, like something like that. That between this is the persons who are. So it's like all pair shortest paths, and the people who get the highest score being along the most paths in the network. So then we have a synchronized view to score them, and a normalized 0 to 100. And so you can see, so that's just like, and then so we're building an analysis pipelining system. We're going to have a data flow transformation system. So you could say, okay, run a centrality, get me the highest scored people, and then run a reachability around them. So I could say, well, I want to investigate, I think those people are insider trading. So here's a simple, or that's one kind of, maybe I'll run a centrality measure. That's another one called closeness. Maybe that's how the leak spread, who leaked the iPhone. So we have I don't know if I have time for analysis. Maybe I'll show a gene example. That's probably a good idea. I promised I would. Like a gene expression project like this. So here I've got network data, interaction model, and I could say, well, I have different microarray data sources. So I've got the data. I'm running like different microarrays, and I'm changing running the experiment. So you can configure these controls. Every tree or table can have renderers, and the renderers go against the data model to update the views. So I'm actually running a, you see how I don't know if you can see, but the view data is changing, So, yeah, so this is just like a gene one. Sorry. If you want me to, I can run an example with a larger data set, but if you give me a second, I'll do it. Oh, good.
Are you using open source projects?
No.
All proprietary?
Well, the only open source stuff we have is like Apache stuff for reading XML. Everything else is Tom Sawyer built. So yeah, we probably some of the best stuff out there. I mean, that's my opinion.
Do you use semantic technology in any of your algorithms?
Semantic technology? Well, we read and write from RDF, and we do Sparkle endpoint support. So we have a bunch. So we have some partnerships, and with RDF stores. Like we work with Oracle's RDF, or we talk with like Franz or other companies who have RDF stores. Yeah, you can see I didn't really show the integration architecture, but you can see here integrators. You can say add an integrator. So you can see database, Excel, text. I mean, it would take me a little while to bind. What's happening in the market is we're getting into these like kind of social services apps, policing apps, intelligence apps, where they have very government specified schema, and we've got to do like loading of this stuff or networking. So we're like used in like Cisco's. So a lot of the stuff is in web technology, multiple web client views. So we've bound with like Dojo, EXTJS, jQuery, a whole bunch of, so there's a whole bunch of like web technology, GWT, EXT, so we're binding with a lot of front-end technology, web frameworks. And so it gets complicated, so I'll just show one fast, quick one, just for speed. So I don't know why it all of a sudden takes so long to load. It's weird. I want to just show one more thing in the Yeah, we've also done in the most recent software. We did one-line electrical diagrams, which are they're kind of like bus branch bar. So these are labeled drawings where it's like buses and substations, and the buses are variable length depending on the connectivity. So they're used in smart grid apps. This one is not very, but what usually happens is they show junction. This one is more simple because we didn't have time, but they're showing like ground and switches, and so that's one example of like bus bar. We also did Google Maps integration in the most recent one, like here you can see. We did rule-driven Google Map views. So you can see here's a multiple view app. You see, so we show our offices like Tom Sawyer software, or, and then we have, you go to a geographical view of that, and it's bound. So you can build web apps that have like geodata, so people, so we're going to try to do things like select a polygon, and that'll send a query so people can like subset the data based on the geo coordinates, or because that gets really important in all these social applications, local apps and all those things. So that's new, and it's all synchronized. So that's kind of, and you can do custom markers and all sorts of showing routes and stuff. So we got pretty far so far, and I just want to show one more drawing, and then I'll. Oh, I didn't show analysis. I can do that quick. This is just for speed. I want to show. This one's pretty big. So it's you can see 10,300 nodes. It's pretty 10,500 links, so it's not a high degree. But so I'll just randomize it. You can see that the randomizers takes longer than the, okay, so I'll run it at 45. That's running. So we have layout cancel. When that cancel stops, the layout's done. Yeah. So that was 8 seconds. So it's like 1,500 notes a second. And oh wait a minute, it's not done rendering. Oh, that's weird. I'm sorry.
Is there any other technical questions that we'd like to ask? Or?
That's strange. So that's not right. Something's wrong with it.
So, in terms of
There we go.
analysis, can you
Sorry.
show correlations when you're doing something? Like, you analyze some data, say, what's the median price, say, of whole, depends on demographic population. So, you're doing the correlation analysis and to represent graphically that?
Yeah, I'll show, if I have a minute or two, I'll quickly show analysis, some of the algorithms we have. Is that help?
Yeah.
So, for instance, like cluster, you have a simple graph like that, and you want to say, give me the, you know, so this one, so we run analysis. It gives me a set of clusters as output, and then we color it in this demo. So that's an example of, you know, this graph has 7 clusters, or here's an example of disjoint paths. Like, so say I have a start and a finish. How many paths between the source and target that are edge disjoint, meaning no link is shared. So if I run it here, okay, it colors 3 different paths. So that's the example. There are 3 paths between these nodes. Or node disjoint means, okay, I should get 2 because there's a node blocking. You know, I run it again. 2. Or minimum cut, you know, is like if I have costs on the links and a source and a target. You know, that's like, well, which bridges do I blow up to do the least damage? Or how does FedEx, if they have a network, how do they check each package at least once with the lowest cost? You know, so they might have data and dependencies. So this one says, given those, you have to check on these 5 paths on these 5 links to do it at the lowest cost. That's an example. So you can see that the total cost is 25, and anywhere else you cut it will be higher. Root cause is another example. So I've got these yellow effect nodes. I want to, what nodes could be the cause in that dependency graph? So root cause is, okay, it tells you in this data set you have to check those 14 nodes. Whatever, why did the shuttle blow up? Or, you know, you have to go back through all the data and check those 14 first. So that you can't do that visually. I mean, you'll miss some. Sorted paths is like given a start and a finish. That's give me all the paths from shortest to longest. So this one says, okay, there are 24 unique paths through that dependency, through that directed graph, and if you click next, it'll iterate them. So that's sort of like give me the 3 routes from San Francisco to San Jose, or so that's so you can like put these algorithms. You can we're building a whole pipelining system in the design tool, so you'll be able to define data flows. Like you'll be able to run chain analysis and then write back to the model and put views at specific points to say, you know, have a large data set, shrink it down, run analysis on that, write it back, and then keep processing. So the idea of like big data patterns is, so people have a lot of data, they want to get to views, but then, you know, like in pharmaceuticals, how did you get there? You need to be able to say, like, you need to let people store the pattern, the data mappings that they've done. So that's the idea of like something we're building for our June release.
So you guys have like principal component analysis or dimensional reduction to take big data sets and shrink them down into something that you can prototype on?
We have maybe I don't understand. Maybe I don't know enough to answer that. But we have analysis and filtering. So I have one example where it shows a little bit of what we're building. So that's sort of how it works now, where you have a set of integrators, data source, and you can put a filter, and then you got a model, and then multiple views. So you can put a filter, so a filter here, filter there. Then we're building a new one where if it's like this, the integrators are running in parallel. So we're going to do, right now we have an in-series integration architecture. It reads one then the other and unifies them in. We're going to have a parallel, like with the controller architecture, parallel load. So that's what this thing represents. So, you know, another data source. So now this one will run in series through another filter. And then we have this thing called analyzers. So you can chain the analyzers, and you know, so we're working on it. But yeah, so the idea is you'll have a data flow as a view in the design tool, and be able to write, you know, yeah. Go ahead.
This is a very impressive product.
Sorry, my demo's not big.
It's very, very impressive. It seems like you've created the Cadillac of model and data visualization tools beyond the needs of a lot of garden variety applications. So, are you targeting the enterprise space primarily?
Yeah. Well, so mostly we've been a licensing company. So we have, you know, like 250 customers or something like that, and in multiple markets. So the idea was we built. So circular and symmetric were for really like network, social. Hierarchical drawing was for, you know, flows, data dependencies, ETL apps, process apps, code analysis apps, and then orthogonal is really about schematic representation, smart grid, ERDs, and then we've done. So we have a whole bunch of. Like to design stuff like this, you have a bunch of, you have what the market wants, and then you have the old stuff you know you didn't finish. And, you know, so we're doing integrated diagramming, we're going to add charts, we have a cloud we're going to take the integration architecture and deploy it on the cloud.
I guess the
So
question
if that
is,
makes sense.
would a single end user benefit from this product, or it seems like it would be a very overwhelming, overarching solution?
Yeah, I mean, most of our customers are building an app, mostly, but we've moved a lot closer through because of the design-based environment. So you can just what would happen is sometimes during, like, I don't want to sell the pre-sales or our, you know, when we're helping our customers, we sort of help build the app for them. So there's a whole bunch of people building like document management apps, smart grid apps. So a lot of it depends on where they're deploying it. Like web apps are getting very, you know, you've got distributed web apps and stuff, and so where the data is coming from, is it schema, you know, do they know the schema, or is it all loading the schema? And then they want to bring controls up on top of the drawings, like 360 views on top of the network model, so they can launch a SNMP call. Or
do you have tutorials online?
Oh yeah. It's
good.
It's tutorial driven. So yeah, I'll just one more second. So you can see it's there's it'll load in a second. So you can see like overview, you know, how to set up a development environment, design, you know, app strategies, tutorials. So you could see like, well, how do I work with an XML integrator? You know, so that's an example XML source, and you know, it tells you how to step-by-step use the designer, or how to work with a text integrator, or how to work, you know, so your text can be in any format. How do you bind to that? How do you work with SQL, or you know, how do you build it? How do you do something with a table view? Or so it's very tutorial based, so to help people. I could keep going, but I should probably stop. Quick.
If I can just follow up on that question a little. If I'm a solo consultant with average, I'm not going to get my hands on this unless I've got a really fat customer. Is that kind of true? Or
oh no, we're not. I mean, we have one-time licenses, annual licenses. We have basically we try to. So what we're trying to do is we license for years.
So I don't have to Cisco in order to.
No. We're working with. So what's happening is we're trying to move up from only being in the software company space. So we have like, yeah, we're doing like we're trying to partner with companies that have like data architect, you know, they have like entity extractors, or they have case management architectures, or they have they're a new database company, or so that's like in the sales, like partnering side, like to go to market with companies, but also we work with lots of you know, basically as long as it's, what's good about the design is our solutions group will help people get what they need. So what's good is it's not a fixed app, because you can't, there's so many markets, it's like, what does someone really want? And we're not IBM, so we can't build like 1,000 apps for everybody, but we can help just configure, you know, where's the data, what kind of views do you want, what are the rules between the data and the views, and then you just say, take that previewed app and deploy it. And we can do it in you know, a couple of hours. Well, it's not that fast, but you know, a week or two, we'd have you up and running. And so we're not trying to, we want people to use it, if that makes sense. We don't have statistical integration yet. There's a lot of things we'd like to do. And, we'd like to have a SaaS system, but it's not, you know, we'd like to be able to let people build a data visualization app with search and just you know, deploy it, you know, so collaborative and social apps and that kind of thing. But it's a lot of infrastructure development to scale that. So that's why cloud has to come first, and then we have a bunch of products that will begin to be deployed on that cloud, and then so we're looking at higher level business components that are ready-made, you know, whatever, process manager, project manager, you know, maybe a little CRM module, database design tool. We kind of come from the platform, you know, or the API space, so we're not really an app maker. But we'll try to just take it up a level and make it that much quicker to deploy. So if that makes sense, yeah. Oh.
We should probably wrap it up this way.
Yeah, should I stop? Oh.
Maybe one more question. We had a few people asking about visualizing large data sets. And you showed us a number of examples that were sort of very concise, understandable with small data sets, really cool stuff with analysis. And then you showed us kind of a 10,000 node graph, and it was pretty difficult for me to understand what was going on. So I'm just wondering, is there a practical limit just in terms of how large of a graph you can interpret and that's sort of useful to look at, as opposed to maybe it's technically possible, but it's just not interesting for people to look at it anymore?
Yeah, I mean, most of the, so a lot of the customers, like in networking, they're trying to have like the high level drill down view. So we have a lot of deep work, like where they have these like really deep nesting hierarchies, like some of the networking companies, like they drill down, like sometimes there are lots of level. But we can do like, you know, like our symmetric, like for instance, that layout is like n log n root n performance. So it's definitely sub-quadratic. You know, it's really about the memory.
So I understand it performs, but have you found there's a practical limit where people just say, this is overwhelming, I can't really look at this, and it's not even, you know, worth performing?
Yeah, I mean, yeah, you can do, well, you know, that's why it's like, what's the viewing technology? So we can do like 50,000 nodes in a drawing without much trouble. But it's just, that's why we just built the search interface, so you can say, search by what attribute, and it'll take you. Because people, they have these drawings, but then they couldn't find the node by name or something. So we just added the search. Yeah, so we did the link navigation I didn't show, but I'll quick. I think that's one of my favorites, and I didn't show it. Oh, okay.
There is a practical limit.
Yeah.
We tend to, you know, there's two camps. You know, you don't control the data input set, but there, you know, we try to facilitate the drilling down and collapsing. We have features where you can collapse and expand nodes in place and high detail from people. Because too much is too much. You know, there's only so much the human mind really can expose, can understand. And generally the drawings don't look as good as they can. So generally what you want to do is we have technologies involved that allow you to hide complexity from the user and then expose them to the complexity when there's enough detail and a focal area of the drawing that they can hover down to.
Okay, well, so with interactivity, it becomes possible to
That's
expand
right.
that.
That's right.
Yeah, so like there's things like hyper, you know, so we have incremental incremental loaders, like you can say, go off the. So the idea is we're going to, as we build this analysis integration, you're going to be able to say off of a particular node, dynamically reach a neighborhood, go back to the data set, and so we have these things like incremental integrators, or actually this might be a good example to show. Or yeah, there's. Yeah, like this is a dynamic one here, where this is like a crawler app, so I'll show it. I didn't really show a time analysis one. So this is actually doing a live, it's scanning tomsawyer.com, retrieving the, it's doing a dynamic indexing of our website and dynamically building the page, content. So you see it scale, and it's incremental layout. So it kind of, yeah, this is an image map front end. So there's a lot of tricks to get this stuff to work. And so you see it build, but trying to keep people's perspective is the key. How do you keep the drawing? How do they manage the, you see how it's mostly stable, and then it gets more data. One more and then I'll stop. And so here in big data, sorry. So I didn't show a time-based one, but we're starting to work in, like this is a Twitter example we built, where I didn't write it myself, but it tweets on the word visualization. So we have a lot of technology to draw a lot. So we're actually in a lot of new apps, like these little REST, reading Neo data sets or objectivity, you're getting a lot of these connected components. So we have a tight packing system, so it does a tight packing of all the components. So for instance, if I, change the size of that and I need to clean it up, you see so it's really clean, and then you could run that. It shows how the tweets evolve through time. So we're trying to play with that kind of, how do people work with time data? I'm not sure this is a useful one, but but it shows how data evolves. Or like another example is time. What happened on what day? So like a timeline. So this is a set of events, and some of them have times. So, you see, so these are the events that happened on a certain day from, or, like I was saying, we have constraints, so you could sequence from, so these are sorting from the start of the day till the end of the day. So you can see they're sorted from bottom to top through the day. So people are trying to build these time-based views, and but this one you only have some of the data has time and some doesn't. So that's an example. And then we have I didn't show the link navigator, but you can, it's a way to navigate data without getting, a little bit. So that's we have that in the web, and so it's kind of nice, nice instead of panning all the time, right? So, so you see here, yeah, from early in the day to later, yeah, and then March 7th, March 8th. So there's a lot of people trying to do this kind of in, time-based apps. So maybe I'll stop. So.
I'll thank the speaker.